Hey everyone, welcome back. So in this video we are going to discuss the design architecture of IRCTC. Those who don't know about IRCTC, for them I would like to give a brief introduction. So IRCTC is nothing but a ticket booking system of Indian Railways through which you can book a ticket from one place to another place, and you can also search a train running from one station to another station. So this is all about IRCTC. Now let's say you are in an interview of system design and an interviewer asked you to design IRCTC. So how would you do? How would you approach this question? So the very first thing that should come into your mind are the functional and non-functional requirements of the system that you are going to build. So in case of IRCTC, what can be the functional and non-functional requirement? Let's see each one by one. So the first functional requirement that we can have is a user profile. User might want to register themselves because it is very common when you go to any website, IRCTC or any website, you create your profile, you provide your basic information, your username, password, email address, phone number, it can be anything, and on the basis of this information, your username and password, you do login next time. So this is about the first functional requirement that we had. The next functional requirement that we can have is a train search. So after registration, you will try to find out all the trains running from one place to another place. Let's say I have to travel from Jabalpur to Pune. So I will find out all the trains running from Jabalpur to Pune. Basically, we have to perform a search, and this search can be performed on the basis of following parameters. These parameters can be anything. It can be a train number, or it can be a source and destination address. Train number, because in Indian Railways each train has its unique number, so it can be one of a parameter. The next parameter that we can have is source and destination address. So we will, in my case, I'm considering Jabalpur to Pune, so I will put Jabalpur at the place of source, and at the place of destination I will put Pune. The moment I'll click on search, I will get number of trains running from Jabalpur to Pune. So this is about the second functionality we had. The next functional requirement that we can have is get train details. So after train search, you will get number of trains running from one place to another place. In my case, I'm considering Jabalpur to Pune. Now you will select one train amongst them based on your preference. Your preference can be anything. It can be suitable arrival time, suitable departure time, or it can be a time taken by the train to go from one place to another place. So based on your preference, you will decide that from which train you have to travel. Let's say you selected a train. Now you will click on that train. The moment you will click on that train, you will get all the details related to that train. It can be a train number, train name, number of coaches in that train, types of coaches in that train. So this information you will get. So this was about the third requirement that we had. The next functional requirement that we can have is get seat details. Now after getting train details, you are allowed to see number of coaches and types of coaches available and in the train. It can be AC, non-AC, it can be anything. And according to your preference and availability of seats, you will select and then you will click on that coach. The moment you will click on that coach, you will get seat details and types of seat available in that train. It can be upper seat, it can be a lower seat. So this is about the fourth requirement that we had. The next functional requirement we can have is ticket booking. So after getting train details and coach details, now you can book ticket from place A to place B. This functionality is going to be very crucial and important, because in this functionality or requirement you will be managing concurrent booking, where multiple users will try to book a same ticket, and we will also be managing partial booking. We will also take care of atomicity, concurrency, consistency, because this is a ticket booking system, so there will definitely be transaction related queries. So this functionality or requirement is going to be very crucial. So this is this was all about the fifth requirement that we had. Now the next functional requirement that we can have is a payment. So after ticket booking, you will pay certain amount to IRCTC. It will be based on your coach. If it is AC, then amount will be different. If it is non-AC, then amount will be different. So it is about the sixth functional requirement that we had. The next functional requirement we can have is booking cancellation. This booking cancellation, sorry for the handwriting. Let's say I have to travel from Jabalpur to Pune, so but then I changed my mind, so I would like to cancel my ticket. Then the moment I cancel my ticket, that seat will become available for others. So this is about the seventh functional requirement that we had. So we are pretty much good with the functional requirements. Now let's discuss the non-functional requirements of the system that we are going to build. So non-functional requirements are the requirements that do not affect the flow of the user, but it rather affects the experience of the user. Now what does that mean? So let's say you have two websites, website 1 and website 2. Website 1 takes 10 seconds to respond to client's request, and website 1 takes 10 seconds to respond to client's request, and website 2 takes 50 seconds to respond to client's request. So you can see that website 1 is taking less time than website B, so website 2. So it is obvious that you would choose website 1 over website 2. So this is one of our non-functional requirement, which we called low latency. Low latency means server should respond to client request in a minimal time. So the first non-functional requirement that we can have is low latency. The next non-functional requirement that we can have is high availability. So the system that we are going to build should always be highly available. In case of IRCTC, it is very important because, as you know, that it is the only platform through which we can book train tickets. So high availability matters a lot in case of IRCTC. So this was about the second non-functional requirement. The third non-functional requirement we can have is strongly consistent. Now what does that mean? So strongly consistent means whatever changes we made should persist in database. Now what does that mean? So let's say two users, user 1 and user 2, trying to book a same ticket. That means they are doing concurrent booking. And let's say user 1 booked a ticket. So this should be immediately reflected to the database so that user 2 will get to know that okay, this seat is reserved now. So this is about the third non-functional requirement that we had. But according to CAP theorem, a system cannot be highly available and strongly consistent at the same time. So how would I avoid this constraint? Here we are considering IRCTC as a microservice architecture. That means we will be having multiple services in that system. So how are we going to avoid the constraint of CAP theorem that says a system cannot be highly available and cannot be strongly consistent at the same time? So how would I avoid the constraint? So we can do one thing, that we can make few service as highly available and can make few service as strongly consistent. Let's say a train search. So train search service, we can make this service as highly available, and booking service we can make this as strongly consistent because we are doing transaction related queries here. So this is about the third functional requirement that we had, non-functional requirement that we had. The next non-functional requirement we can have is highly concurrent. Now what does that mean? So as you know, it is a ticket booking system. Multiple users will try to book a same seat. That means they will be doing concurrent booking. So we should make a system in such a way that system should handle it only one request at a time. This can be performed by applying different types of locking mechanism. It can be pessimistic lock, optimistic lock. So we'll see that in later videos. So this was about the fourth requirement that we had. Now we are pretty much good with the functional and non-functional requirements of IRCTC that we are going to build. In the next video, we will be discussing about services, what type of services we can have. Basically, our functional requirements will be further translated into the services. We'll see that in the next video. Till then, bye bye. Thanks. Show some love. Hey everyone, welcome back. So in a previous video we discussed functional and non-functional requirements of IRCTC. In this video we will be discussing services our system can have. The functional requirement that we discussed can be translated into services. We'll see how, but let's first see what services actually are. So services are nothing but the functionalities that our system can have. It can a train search functionality in which user will try to find out trains running from one station to another station, or it can be a booking functionality in which user will try to book a ticket from one place to another place. So services are basically functionalities. Now let's see how we can convert those functional requirements that we had to services. So the first functional requirement that we had is user profile requirement, which can be translated into user profile service. Train search, get train details and get seat details. These functional requirements can together be translated into train search service. And the next functional requirement that we can have is a booking requirement, which can be translated into a booking service. So this is how we can convert functional requirements into a services. Now first we will see what each service is functioning, what kind of data these services will be using, and then we will see how we can model our data, and then finally we will see how each service is functioning. That means the actual implementation of the service. So let's start with the user profile service. So first service we have is user profile service. So when you go to any website for the first time, you basically create your profile there. So the first functionality that this user profile service will provide is create profile. Now let's say after some time you want to change your phone number or email address, so there should be a functionality through which you can modify your data. So there will definitely be update profile functionality. And let's say if you want to delete your profile, so there should be a functionality through which you can delete your profile. So these kind of functionalities user profile service will provide. User profile service will have the authentication mechanism. That means this service will interact with the client first. Now let's see what kind of data this user profile service will manage. So since it is managing users profile, so there will definitely be user ID, then user's name, so username. Then we can have email address to send ticket details, and then we can have phone number. So this is the important data that we will be managing in user profile service. The next service that we can have is a train search service. So after registration, you will find out all the trains running from one place to another place. You will get train details, you will get seat details. So you will be managing these functionalities in train search service. And what kind of data you will be managing in train search service? So they can be train ID, train name, number of coaches in that train, and number of seats available in that train. So this is the important data that you will be managing in train search service. There can be more data, but this is the important and required data that I can see right now. The next service we can have is a booking service. So after train search and getting train details and seat details, you will try to book a ticket. So you will try to book a seat, basically booking service. So this functionality will be in the booking service. And what kind of data you will be managing in the booking service? So there will definitely be a booking ID and train ID. Booking ID will be as a primary key, and train ID will be present as a foreign key. Here they will definitely be user ID. It will also be present as a foreign key. Then we can have seat ID, also foreign key. Then source and destination address, from where you want to start your journey and where you want to end. So this will also be present. So this is the major data that I can see in the booking service. So we are pretty much good with the services now and the data that we had. So on the basis of services and the data available, we can identify that our data is very well structured. And since it is a ticket booking system, so there will definitely be transaction related queries. So transaction related queries, that means you will take care of asset properties. And if you have to take care of asset properties, who's better than relational databases? So yes, relational database can be our choice, because data is well structured and it can be present in the form of tables. So yes, we can use relational databases. So we are pretty much good with the services and database. In the next video, we will be discussing functionality of each service. That means the real implementation of services, how we are going to search trains from one station to another station, and how booking will take place. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in previous videos we have discussed functional and non-functional requirements of IRCTC, and we have also discussed a different kind of services that our system can have. In this video we will be discussing the actual implementation of each service, that means how each service is going to function. So let's start with the user profile service. So when you go to any website for the first time, you basically create your profile there. So let's say this is the user you have, and this is your user profile service. So this user will make a request with his username and password and other information. It can be phone number, age, anything. And on the basis of this information, user profile service will create user's profile and will store this information into the database. And then this user profile service will respond to user's request that okay, your profile has been created now with the status code of 201. Now this user profile service will have the authentication mechanism. So the same user comes to this website again with his username and password. So this user profile service will authenticate the user that okay, if she or he is an authenticated user, then this user profile service will allow user to access further services or pages of the website. So this is how it works. Now let's say tomorrow a new service comes in, let's say a train search service, and it doesn't have the information of username and password. So there will definitely be a logic in that service to access user profile service for authentication. Let's say another service, booking service comes in tomorrow, and it doesn't have the information of username and password. So there will definitely be a logic in that service to access user profile service for authentication. Let's say thousands of more services comes in tomorrow. So they will also have the logic to access user profile service for authentication. So you can see how much code duplicacy there will be. And here we are considering IRCTC as a microservice architecture that separates the logic based on services. If we will have code duplicacy in each service, then what is the need of using microservice architecture? So we need some kind of routing mechanism to remove this code duplicacy problem. So let's see how we can remove this problem. So now let's say we have this user and two services. First is a user profile service, and another one is train search service. Train search service. Now let's say this user wants to search a train running from one station to another station. This user profile service will have the authentication mechanism. So we need some kind of routing mechanism to route our request to a particular service. So this routing mechanism is nothing but a gateway. This gateway interacts with the client. No one interacts with the client directly, only gateway interacts with the client. So this user wants to search a train from one station to another station, so he will make a request to search a train running from one station to another station. So first this request will go to gateway, and for authentication this request will go to user profile service with the username and password. After authentication, if let's say user profile service authenticate the user that okay, this he or she is an authenticated user, so this user profile service will send yes or no response to gateway. And if the response is yes, then the request to search a train running from one station to another station will be redirected to this train search service. So this is how gateway removes the code duplicacy problem. Hey everyone, welcome back. So in previous video we have discussed the user profile service, how user profile service actually functions. In this video we will be discussing about the train search service, how we can search a train running between two stations. But before watching this, let's first see the architecture of IRCTC, or we can say IRCTC as a microservice architecture. So we have these three major services: user profile service, booking service, and then train search service. And we have this client that interacts with the gateway. So client only interacts with the gateway, no one interacts with the client directly. So first user will make a request to create his or her profile. So for that we will be using user profile service that will create user's profile. Then this user profile service can use email service to send verification code. This user profile service will have the authentication mechanism, so it will authenticate the user whether he or she is a part of that website or system or not. And then on the basis of that, gateway will route that request to a particular service. Let's say we have a request to search a train running from station A to station B. So the first request will go to user profile service for authentication, and after authentication, if the user is authenticated, this gateway will route that request to this search service. So this is how our system is going to work. Now let's discuss the second functionality or service that we have, that is train search service. So how we can search a train running from one station to another station. So let's say we have a train T1 that starts from Jabalpur and ends at Delhi. So for train T1, start point is Jabalpur and end point is Delhi. And in this journey from Jabalpur to Delhi, this train T1 goes from different routes and different stations. From Jabalpur, let's make stations. This is Jabalpur, this is Sagar, this is Agra, Mathura, and this is Delhi. So from Jabalpur to Sagar, this T1 train runs on R1 route. From Sagar to Agra, this train runs on R2 route. From Agra to Mathura, this train runs on R3 route, and from Mathura to Delhi, this train runs on R4 route. Now let's say we have to find out the trains running from Sagar to Mathura. So how we can find that? So for that we have a route table. Now let's see the entries in route table and understand what it represents. So for station Sagar, T1 train runs on R1 route. For Agra, T1 train runs on R2 route. For Mathura, this T1 train runs on R3 route, and then for Delhi, this T1 train runs on R4 route, and these are the arrival and departure time of the train. Now one thing you can understand is that if you want to go from Agra to or let's say Sagar to Mathura, train ID is not going to change. Now what does that mean? So let's say this is the Sagar station and This is the Mathura station you have, and this is the T1 train. So you took a train T1, and when you will reach to Mathura, train is not going to change. That means train ID will remain the same. That means we have to take source station and destination station with the same train ID. Routes ID can be different and station IDs can be different. So this is how we can search a train running between two stations. Now let's see the SQL query. For that, in my case, I have to travel from Sagar to Mathura. So first I will see which train goes from Sagar to Mathura. So this T1 train has the station Sagar, and then this T1 train has also the station Mathura. That means this train runs from Sagar to Mathura. Now let's see the SQL query for better understanding how we are going to search trains running from Sagar to Mathura. So for that we have two SQL queries. First SQL query gives me the detail of all the trains running between Sagar to Mathura, and then the next SQL query gives me the detail of a particular train that runs between Sagar to Mathura based on the train ID. Now let's see how it actually works. So we mentioned R1 and R3 here. Why? Because we want to start our journey from Sagar. So for that I'm considering R1 route, and I want to end my journey at Mathura. So for that I am considering R3 route with the same ID, with the same train ID. So that's why we mentioned R1 and R3 here. Then we will compare train IDs. They should be same because we will be traveling in a same train. We will start our journey at Sagar. So train is not going to change, it will remain at the same. So train ID will also remain at the same. Then we will compare the source address, that is Sagar, and this destination address, this is Mathura. So this is how we will perform a search, and this is all about the train search service, how we can search a train running between two stations. In the next video we will be discussing the most important service, that is a booking service. So till then, bye bye, show some love, thanks. Hey everyone, welcome back. So in this video we will be discussing about booking service of IRCTC. This video is going to be the last of this playlist, so let's get started. So booking service is very important and crucial because in this booking service we will be talking about partial booking, concurrent booking. We will also take care of asset properties, that is atomicity, concurrency, consistency. So before understanding how booking service actually works, let's first see few terminologies that we are using. First is a concurrent booking. So concurrent booking is nothing but a booking in which multiple users will try to book a same seat. So let's say we have this seat, let's say S1, and we have 3 users, and all the 3 users want to book the same seat. So this is about the concurrent booking. And another terminology that we have is a partial booking. So partial booking is nothing but a booking in which user doesn't want to be the part of whole journey or complete journey. So let's try to understand this with the help of example. So let's say we have a train T1 that starts from Jabalpur and ends at Delhi. So the complete path would be Jabalpur to Delhi. Now if user doesn't want to be the part of complete journey, then this booking will known as partial booking. Let's say we have intermediate stations between Jabalpur and Delhi. We can have Sagar, Agra, and we have Mathura, let's say. So if user wants to travel from Sagar to Mathura, so this is known as partial booking. Now let's try to understand the first case, that is concurrent booking. So for that we have a seat mapping table in which we have a seat ID, train ID, then we have a station ID from where you want to start your journey. Then we have a seats booked array that represents the seat ID that are already booked by the user or allocated to the user. Now let's say we have a train T1 in which 20 seats are present and 4 coaches are available. So what is the first step that you are going to do while booking a ticket from one place to another place? You will definitely check the availability of seats, whether the seat is available or not in the train. This involves checking all the stations between source and destination in the route table, and we will also see how many seats have already been allocated to the users, and we will see this in the seat mapping table. So let's say till Sagar we have 1, 3 and 4. these are the seat numbers. So 3 seats have been allocated till Sagar, and we have total number of 20 seats available in that train. Now let's say a new user comes in and wants to book a ticket from one place to another place. So he will easily book a ticket because right now seats are available. Now let's see where log comes into the picture. So for that we have this seat mapping table in which we have different seat IDs. So let's consider this first one, that is seat ID 1, which have already been allocated to some user. Now let's say a new user comes in and wants to book the same seat. So how we are going to stop him? So for that we will be putting log in this entire row. So this will stop user to perform any read or write operation. This log will be a pessimistic log in which user won't be able to perform any read or write operation. That will be a forced log. So this is how we can maintain concurrency. We will allow only one user to perform a task. So this is about the concurrent booking. Now let's try to understand the second case, that is partial booking. So for that we have a train T1 that starts from Jabalpur and ends at Delhi. So in this journey from Jabalpur to Delhi, it goes from different stations and different routes. So the intermediate stations between Jabalpur and Delhi are, it is Sagar, let's say, and we have Agra, then we have Mathura, and then we have Delhi. So these are the intermediate stations between Jabalpur and Delhi. Now let's say we have 4 users. User A, we will assign seat number 1 to user A. We will assign seat number 2 to user B. Then we have user C. We will assign seat number 3 to user C. We will assign seat number 4 to user D. Now let's say this is Jabalpur, this is Sagar we have, then we have Agra, then we have Mathura, and then we have Delhi. So these are these stations. Now let's say user A wants to go from Jabalpur to Delhi. User B wants to travel from Jabalpur to Sagar. So this is user B. This user C wants to travel from Sagar to Mathura. So this is the partial booking. This Sagar to Jabalpur to Sagar and Sagar to Mathura. These are the partial booking. So this is user C. And then we have this user D who wants to travel from Jabalpur to Mathura. So we have this user D. As you can see, 3 users, user A, user B and user D wants to start their journey from Jabalpur. And their seat numbers are 1, 2, 4. They want to start their journey from Jabalpur. Now for this user B wants to end his journey at Sagar. So you can see that when you will reach to Sagar, this seat number 2 will become available again. So this is about the partial booking. This is how you can manage concurrent booking and partial booking in IRCTC. So this is all for this playlist. I will also upload videos on Uber, Tinder and Airbnb, booking.com. So till then, bye bye. Show some love. Thanks.